Okay, Lewe 3, second go. This is so difficult for me to translate the information that I receive for other people. It's the Cassandra effect. It's really, really hard. The Matrix works really hard to make it difficult for you to understand me and for me to speak and to translate what I'm saying. And so I found just making a video, I really struggled, because this ultimate translation that's coming now, the revelations off the back of Lewe are so great that they're making it as hard as possible. So bear with me, please. And let me talk about this document. Because the provenance of this document is really important to understand. So in 1915, Dr. Lewe, and I'll just show you the cover a second. Let me just have a look at it. So Victor Lewe has gained a physics degree in 1906. He's under Alexander von Brill. He's noted in Wikidata as the student of the year with a marvelous dissertation which contains things of wonder. 1906. In 1915, which is this paper, he's already gained his diploma in engineering. He's now seeking a doctorate in engineering. It's a really incredible feat of intelligence that Victor Lewe is demonstrating here. 2 doctorates in 2 different disciplines. It's almost unheard of, and he should be famous. And so he wins his doctorate. In 1916, he becomes Dr. Squared, Dr. Victor Lewe. And then in 1920, he becomes a professor in Berlin University with the help of Hans Reisner. And then he's promoted after 6 or 7 years, and he's a senior professor for 17 years in Berlin University in the civil engineering department in strength of materials. Now, does that say to you this document has doubt about it, or would you say this has superb provenance? Victor Lewe is noted in Carl Eugen Kurra's book, 2018 book about the history of Eisenbettenbau, reinforced concrete design in Germany, particularly. Lewe is noted as pushing forward in 3 different areas and making real scientific progress in 3 different areas. Strength of materials. When he was a consulting civil engineer, after he left physics, he worked with Hans Reisner, who worked with Junkers. And Junkers and Reisner designed the corrugated surface plane that Junkers used and started to develop. And Lewe would have been involved in that because it's exactly his field. It's strength of materials, it's shape of materials. What's the shape of a material? How do you make it strong? That's Lewe all over, bringing physics to bear on that problem within corrugated steel in this case. Now, a really smart man, served under a really brilliant mathematician cosmologist, goes for his 2nd doctorate, gets it, becomes a professor, 17 years. Okay, he's right, isn't he? Yeah, he's right. So all I'm doing now is I'm going to stand on Lewe with the rest of my material. Now, I think I'm going to do this so that that will be Lewe 4, I think. Because let's do the introduction here. So this document, I wrote it in 2008. It's for my thesis for my civil engineering degree, and it's about investigating the loadings in concrete water tanks. The question was, can I work out a way of doing it mathematically without using a coefficient table? That was the question that I was asked. The answer I came up with was no, you can't. But what I found was something amazing that was not being referenced properly within the canon. This is a photocopy of 2 pages from the 1915 issue of the Handbook for Eisenbettenbau, the Manual for Reinforced Concrete. It's a section written by Victor Lewe, and there was a foreword that introduced this section that said, I am trying to translate the language of physics of elastic membrane theory into a practical application for engineers to use. He says the theory is very complex and you don't need to know all the detail, but here's the detail you do need to know. At the time, I said I disagree. I'd like to see that theory because I'm really interested in this, but I couldn't find it, and so I just knew it existed. But this is the interpretation of it, and I just want you to see something quantum here. Position, momentum, load. Load. Where is the load? Where is it? What is the quality of the load? That's it. So that was my understanding of where I'd gone to in terms of quantum in 2008. A few months ago, I remembered that I realised that the work I've been doing on quantum for the last couple of years, suddenly E equals mc squared was looking like the coefficient trick that I learned about in 2008. That it's a trick using matrix calculus. A clever one. You can take any point and you can split it into a coefficient table, analyse that point. And when it's low in a beam, it could be a centimetre point, but you could take that to infinite scale and just go right down into the atom and discover what's going on. And so I realised there was a trick. And so I dug out that thesis, read it, went, wow, I already know this. I wonder what that document is that Dr. Lewe is talking about. This one about from physics. He's hinting that there's a deeper underlying physics that's available in 1915 that backs up what he's saying. And because I can't get hold of the 1915 one again now, it's vanished, then I can't follow up the exact reference. But I don't need to. So I searched it online and I found this document. It's Victor Lewe's dissertation to earn his second doctorate in engineering, and it is the document that he discusses in the handbook for Eisenberg. It is the way that he is interpreting the best physics from 1915 in elastic membrane theory, strength of materials, atomic bomb theory, into engineering without bringing in the atomic bomb stuff. The energy, because in this document, he has discovered the energy, the positive moment. And so that's where I'm going to investigate. So Lewe 4 coming up, and I'll just start with Lewe, we'll skip through it, and then we'll get into these wave patterns. And you'll start to see how Lewe is proving the models that I'm showing, the visualizations I'm giving you, are just my visualizations. You can put your own in once you understand the concept. You build a model in your mind, a visualization that really makes sense intuitively, and then we're backing it up with Lewe, a proven provenance document that lies in the heart of science right now that I want to bring to bear on my quantum stuff. And then you'll find it's our quantum stuff because you've all been doing it. And we'll see the future's begun. So you can see why I'm excited and I haven't bothered shaving. So Lewe 4. Ready?